drugs, or ideas, what you consume influences who you become. On the Mind and Matter podcast, we learn together from the best scientists and thinkers alive today about how your mind-body reacts to what you feed it. Before starting Mind and Matter, I spent 10 years in academia doing scientific research. I got a Ph.D. in neuroscience where I focused on neuroendocrinology and the neurobiology of behavior, and before that, I specialized in molecular, developmental, and evolutionary genetics. I use my scientific background to help parse and translate the information that guests share on the podcast. In addition to the podcast, I write long-form written content inspired by the show where I integrate what I've learned across episodes. I also have a free weekly newsletter where I provide you with upcoming guests, share links, and provide commentary on scientific studies and research that I'm reading, and more. Visit mindandmatter.substack.com to find all of my content. If you're getting value from this content, please consider becoming a paid subscriber to the Mind and Matter Substack. For just $5 a month, you'll get early access to episodes and other content, full episode transcripts, and I'll prioritize answering your questions in emails and the comments sections. You can also support me by checking out the links in the episode description to my affiliate partners who make various health and wellness products that I use and enjoy myself. You'll receive a discount and help support the podcast that way. And if you want the benefits of a paid subscription, but it's not in your budget, simply sign up for my free weekly newsletter, send me an email, and I'll give you a complimentary paid subscription. Word of mouth is the best way to help the podcast grow. So if you like what I'm doing, please share your favorite episodes with family and friends. The purpose of the podcast is to provide you with information obtained largely from primary sources, the people doing the research and producing new knowledge. This content is never meant to serve as medical advice. And with that, enjoy the episode. Hey everyone, I want to take just a minute to tell you about a really cool health monitoring device I've been using called Lumen. It's a handheld, pocket-sized device with a sleek design. The Lumen device measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs for energy. I use this device in the morning or before bed or after meals or after workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I needed to fast and how hard I needed to exercise to promote fat burning. Being able to track whether your body is burning fat versus carbs will help you figure out how your body responds to your lifestyle and whether or not your weight loss and fitness strategies are actually working. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. Their easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more and use the code MINDMATTER, MINDMATTER, to get 10% off your Lumen device today. That's on top of the site-wide sale they are currently running, and the Lumen device is eligible to be paid for with FSA and HSA health accounts. Check out the link in the episode description for more info. Can you just start off by telling everyone a little bit about yourself, what your background is, and what you do?
Okay, so I think of myself as an investigative science and health journalist. Others disagree. Studied physics at Harvard, wasn't very good at it, got a master's at Stanford in aerospace engineering, and then went into journalism and science journalism, and then beginning 40 years ago with my very first book, found that I was obsessed with bad science. It's often known as pathological science, or the science of things that aren't so. My first book was about high energy physics, and I was embedded with collaboration at CERN, the big European physics lab outside of Geneva, for 9 months while I watched them realize how they had screwed up the interpretation of this very high profile experiment. My second book was on cold fusion, which was the sort of great scientific fiasco of the second half of the 20th century. And after I was done with cold fusion, my friends in the physics community, that book was called Bad Science. And my friends in the physics community said, if you're interested in bad science, you should look at this stuff in public health. It's terrible. So I was, and I did, and they were right. That's a short story. I first did a piece on this idea that the electromagnetic fields from power lines can cause cancer. They wrote that for the Atlantic. That was based on the field of observational epidemiology, and everything I had learned from my first two books about what it took to do science right was considered an unnecessary luxury in the field of observational epidemiology because they couldn't experimentally test their theories. They didn't think it was important to experimentally test their theories. And so I've been writing about epidemiology ever since.
Why do you think that is? Why do you think it's not? Why do you think that they think that way?
Because they have no choice. It's essentially an observational science. When in the infectious disease world, you can basically test your theories by removing access to the vector of the infectious disease. But in the chronic disease world, classic example, saturated fat raises the risk of heart disease. In order to study that experimentally, since you're looking at a chronic disease state that develops over years or decades, you need an extraordinary amount of subjects who will adhere to, say, a saturated fat rich or poor diet for years to decades, long enough that you could see a significant difference, if the hypothesis is correct, in chronic disease rates. Those experiments are exceedingly hard to do. They tend to cost tens of millions of dollars, if not more. And then it gets tricky. Since they've invariably tended to refute the hypotheses, the community has considered them unworthy of further pursuit. They'd prefer to tell us that the hypotheses are likely enough to be true, that we should change our diets. And when I moved into nutrition in the late 90s, I've been writing about and reporting on those issues ever since.
Mm-hmm. Yeah, I recently wrote a piece that had to do with nutritional epidemiology and just how much of it is basically total garbage. They often collect data through questionnaires that are self-reported from people that can't possibly measure what they say they're measuring with any degree of accuracy. And then from there, basically just go on statistical fishing expeditions, and you're inevitably going to find some things that are significant and report on them. And not only does that happen, do those studies get published, but they often get a lot of public attention and media attention, which tends to propagate in people's minds the notion that the headline results are in fact true and they're based on sound science, when in fact they're not.
Yeah, although, and I completely agree with you. Except I think that's not the major issue when it comes to nutritional epidemiology. Even if they could measure the diets perfectly, physical activity and diet perfectly, you still, from an observational study, it's this cliche, association is not causality.
Mm-hmm.
You ultimately end up with only an association that tells you that people who engage in a particular dietary behavior or physical activity related behavior have more or less risk than people who don't. And now what you have to determine is that risk determined by the behavior, or is it determined by the type of people who engage in that behavior? So for instance, the classic example, and there's two now, ultra-processed food consumption and the benefits of mostly plant diets and the relative evils of meat consumption.
Mm-hmm.
And it's funny, this was captured for me 20 years ago by a friend who said it's like they're studying, vegetarians in Berkeley who eat at the famous restaurant Chez Panisse after their yoga practice and comparing them to truck drivers in West Virginia who eat at Denny's, and then saying that the difference in their health status is the meat consumed. Mm-hmm. And that is maybe a little bit hyperbolic, but even saying maybe might be a hypothesis. You're basically taking all the people, when you study ultra-processed foods, for instance, which is the latest fashionable research, is an article about it in the New York Times today. People who eat a significant amount of ultra-processed foods are very different than people who don't. Mm-hmm. And people who don't because they're health conscious.
Yes, you're saying that other than the other than the fact that one group eats ultra processed foods and the other doesn't, these people are different in many other ways that, and
Just
that's
that you can
why.
say, yeah, you can say ultra processed, the avoidance of ultra processed food is a marker of health consciousness.
Mhm.
And not only is it a marker of health consciousness, it's a marker of having the socioeconomic status to be able to afford to prioritize health consciousness over other issues.
Mhm.
The assumption of the studies is that the people are, in effect, equivalent. The only difference is that one eats ultra processed foods and other don't. They'll try to correct for things like cigarette smoking and weight and alcohol consumption, obvious problems, but the effects they're seeing are so tiny they could easily be explained. And I would bet my kids' college education on this, that they are explained by the difference in the type of people who eat ultra processed foods versus the type who don't.
Mhm.
But these studies are relatively cheap to do. There's dozens, if not hundreds, of these population cohorts out there being studied. Now you see this trend where you even get researchers from China, most prominently, who can basically go into the databases that have been collected and publish papers retrospectively based on. When you said they're mostly garbage, yeah, it's garbage in, garbage out. But there's no way to even determine whether the garbage in has any causal effect on the garbage out, because you're left with an association ultimately. It's, to me, one of the two or three most important issues in nutrition science, but the nutritionists don't care to address it because it is their livelihood, or at least
Mhm.
so I think.
Mhm. And what are some of the factors that perpetuate this research? A lot of this type of research gets done, a lot of papers get published year after year after year. What's propelling that forward?
Well, the research gets funded. To stop funding the research is to acknowledge that there might be a reason to stop funding the research, which means there would have been a reason to never fund it to begin with. The researchers who do it, and I know these people, and I've actually co-authored papers with several of them, they fundamentally seem unconcerned with whether or not they're getting the right answer. They're so convinced they are that they don't see it as valuable to do the research necessary to demonstrate that to the rest of us. And ultimately, if you think of an association as generating, and this is how it used to be thought of back when I was young, you have an association between, say, eating a mostly plant diet and longevity. So that generates the hypothesis that eating a mostly plant diet will make you live longer. Infer causal hypothesis. The way you test hypotheses are in experimental tests. You can look for what they call consistency. So you look in different cohorts to see if the same hypothesis exists, but it's quite the same association exists, but it's quite likely that it does, because you're seeing the same confounding factors in every population in which you look. So ultimately, you have to do an experiment, and the experiments are these randomized clinical trials. And as I said, they're exceedingly difficult to do. They're very expensive, and for the most part, whenever they've been done, they've tended to fail to confirm the hypothesis. So you have a body of researchers who are, in effect, using a tool that might be incapable of doing what they would like to claim it's doing. And they're not going to stop because they get funded to do it. They have students who have to get Ph.D s. You know how this works. Those students have to generate papers and to put in the effort to find out if they're really correct or not, or even to examine at any great depth the possibility that all their findings are being confounded by the kind of issues I'm talking about, and other methodologists, as they're known, have complained of, is to potentially put themselves out of business.
Mm-hmm. So,
And
so So
Very few of us
testing some, sorry, there's a little bit of a lag, I think. So testing a lot of this stuff experimentally could potentially put them out of business because it could invalidate, finding all of these associations in the first place. But even more fundamentally, I think the types of clinical trials necessary to test the work that we're talking about are so big and so expensive to run that in practice, most people can't run most of the tests that would be necessary. So we're in the situation where there can be very little formal testing of the hypotheses that come from these associational studies. And so we're just stuck in this loop, this merry-go-round of more and more associational studies that get more and more attention, that justify doing more of it, all while there's really no way that this stuff's ever going to get tested because it's just too expensive and too difficult to do the requisite studies.
Well, again, it depends where your priorities lie. Okay. So if your priorities, and I've written about this in the past, and I helped co-found a not-for-profit that tried to solve this problem, even though it eventually evaporated. I started my career, as I said, I was embedded for 9 months. We say embedded now. I lived at 9 months at CERN, the big physics lab outside of Geneva. I lived in the hostel on a lab. I spent from 16 or more hours a day with the physicists, watching them realize how they had misinterpreted their experimental results. The physics community has specific questions they want answered. They know what they agree with these questions are. They agree that they're important, and they pretty much agree on the technology necessary to test them. And then they're willing to pool all their efforts into getting those experiments funded. And those are these now $10 billion plus particle accelerators with their $500 million to $1 billion detectors scattered around them that are all aimed at answering specific questions. In the military, you have naval destroyers, for instance, that cost $1 billion each. And last time I looked at one class, there were like 70 of these out there because we consider protecting our freedom with a viable Navy to be an extraordinarily important endeavor. The argument we've made, particularly with the obesity and diabetes epidemics, is that these epidemics are costing, direct cost to the healthcare system of diabetes is pushing $1 billion a day. You include diabetes and obesity, you probably double that. I forget the exact number,
but billions of dollars per day.
So we're talking hundreds of billions of dollars a year in societal costs, plus the emotional and the human health burden of living with these disorders. And the question is, how much do you want to spend as a society to solve them? Because you're not going to solve them from these observational studies. You're not going to solve them by giving us yet more advice from these that assume that these associations are causal when there's no meaningful reason to assume that. The experiments could be done. I mean, if people want to make the effort, the problem is we have a research community that is fully funded to keep doing what they're doing. And we have a sort of philosophy that's willing to blame the continued increases in obesity and diabetes on the food industry and ultimately on the individuals for not eating wisely or eating in moderation and exercising. And so there's a sort of perfect concoction of assumptions that allows people to say, we're doing the best we can. What more do you want from us? And if I challenge any particular individual in the community, as I've done, they will say, what do you want from me? And I'll say, well, I want you to care enough to say the current state of affairs is inadequate in the face of a human tragedy that's been building for decades. And,
so it sounds like it sounds like what you're saying is basically that there are social forces at work which dictate how research is being done. And so in the general realm of nutrition, epidemiology, and related fields, it's not the case that the questions around what causes obesity, doing the right experimental tests of various ideas. It's not that these things can't be done. And this is an insurmountable problem. We could structure the university industrial complex, we could structure the research world so we could pool resources and do the big expensive studies that would be necessary to address some of this stuff. But for whatever reason, social forces are at work that are preventing us from utilizing resources in that way. And we're just sort of on this treadmill of kicking out, association after association after association, and saying we're doing the best we can.
Yeah, and pushing for better and better drug therapy for the diseases out there. Among the thought constructs that perpetuate this thinking. So on one hand, clearly the obesity and diabetes epidemics are triggered by environmental factors. And by environmental, I mean lifestyle, diet and lifestyle. So it could be lack of exercise, sedentary behavior, could be eating too much, could be the refined carbs and sugars in the diets, as I've argued, could be the seed oils, as others have argued, could be some combination of this stew, as others have argued. There's a lot of hypotheses floating around out there. Many of them are dietary hypotheses, and it would be naive to think that diet isn't a trigger. And then the question is, what aspect of diet are we dealing with? The assumption is that nobody wants to change their diet. That given a choice between diet or pill, people want to take pills. This is why the GLP-1 agonist drugs have gotten such extraordinary attention. Hey, lo and behold, you don't have to diet. Or we have a pill that'll help you diet, as the case may be. So pharmaceutical companies will spend billions of dollars developing these drugs because they also expect to get returns from it. If you want to spend $1 billion for a clinical trial testing the carb hypothesis or the seed oil hypothesis, the best possible scenario from a public health perspective is it turns out to be true. And now you're telling people not to eat seed oils or not to eat refined grains and sugars.
And it's in no one's commercial interest for that
to no one's commercial interest. And the research community.
In fact, it's not simply that people won't be told to buy new drugs. It's that they'll be told to stop consuming some of the things they're already spending their money on. So it's actually against potentially people's interests.
Yeah. And despite the government intervention to push, as I wrote about in my books, and Nina Teicholz, my colleague, has written about in her books, to push people to low-fat diets and low-saturated fat diets, the government has never gone after a particular food. Once it's generally recognized as safe, once it has GRAS status, or if it inherits GRAS status, the government isn't going to go after it. Nobody's going to say you should avoid processed foods, because ultimately they're saying, like, would you be healthier if you never eat a Snickers bar again, for instance? And I would argue, much as I loved Snickers when I was a kid, that the answer is probably yes. But the Food and Drug Administration doesn't see that as among their issues. The flip side is, if you could prove it's addictive, cigarettes were addictive, we could go after cigarettes because they were addictive. But even then, you don't make them illegal. You just counsel people not to smoke them. And alcohol, everybody accepts that alcohol has deleterious consequences, both for chronic diseases and for abuse, but we don't make it illegal. We just make kids have to wait until they're 18 or 21 before they drink responsibly. So, I always thought, if we can do the experiments, if we could convince the obesity researchers and the chronic disease researchers to do the correct experiments, we could get a trickle-down effect where the physicians, the health organizations, will at least know the correct advice to give. They'll get off their sort of conventional, probably deleterious guidance and do the right thing. But again, it starts with people doing the experiments, and we've talked about that.
I want to get into, what we know about obesity and its causes, what some of the major models are out there that scientists use to try and understand obesity and what's driving it. Um, to lead into that, one of the most sort of telling experiences I've had since doing my PhD. So I finished my PhD in 2016. It was in neuroscience in the Department of Endocrinology, Diabetes, Metabolism at Beth Israel in at Harvard Medical School. So I was in a lab where we were doing neurobiology to try and understand things like feeding behavior. And I went through the whole thing, and coming out of it, in the years coming out of it, when I started studying and getting interested in metabolism and diet more holistically, not just thinking narrowly about the brain. One thing I quickly realized is for my entire PhD, the entire time, every paper written, every experiment done, we implicitly assumed that it was clearly true that obesity comes from eating too much and or not moving around enough. And the name for that basic way of thinking is called the energy balance model. And as far as I can tell, it's still sort of the dominant model, both in general in people's minds implicitly, but also among scientists. So can you just start off by telling us what is the energy balance model of obesity, and what is it basically postulating?
Okay, so I'm going to ask you a question
Okay.
since this is what you studied. I always do you know the provenance of the energy balance model? I mean, you've read my books or at least some of them, so you might have picked it up from there. But if this was a physics podcast and we were discussing relativity or general relativity, and then I said to you, who came up with relativity, or even who came up with the electroweak theory, or quantum chromodynamics, the theory of this strong force, and you were a physicist, you'd be insulted that I asked you.
Yeah, yeah.
But the question becomes, if I ask you, the energy balance model is in effect the central dogma of nutrition research and obesity.
Mm-hmm.
What's the origins of it? Who's came up with that idea, and based on what evidence? And again, if it was physics and I said relativity, you would not only say Einstein, but you would say general relativity. I forget if it's general or special, was tested by who's the guy who went to Africa to film the
I forget his name, but I know the story. And yes, special
yeah.
relativity was Einstein, and then he did general relativity after that. There's everyone sort of everyone who's interested in that area of physics also knows like the history of science and the players
Yeah.
involved. Same thing for
And
molecular biology, the discovery of the genetic code, Crick,
well,
Watson, Linus Pauling, the whole thing. But for this
yeah.
field, and this is you framed this beautifully, because I'm gonna embody what you're trying to pull off here. I can't tell you exactly. I can't give you a name. I don't know if there is
And
a person.
and this is what's interesting, because in physics and even in molecular biology, you will learn the history of the field. In physics, you basically learn physics by the
Yeah,
history of the field, because as you go along, it
yeah.
gets more and more complicated. So
My original training was in genetics, molecular biology, and for those listening, I've just pulled a book that was right behind me. It's called The Eighth Day of Creation. It's like
yeah.
the Bible of the history of molecular biology. And if you go into molecular biology or genetics, you're probably going to read this book and be completely enamored with it.
Well, also it's fascinating books. I recently reread. I knew Horace Freeland Judson in my youth. He once said of my research for cold fusion and my cold fusion book that I did more research for the stupidest scientific subject than anyone had ever done in the history of journalism. Um, that book, not only do you get it's an oral history mostly, and not only do you get people talking about what they did and when they did it, you get descriptions of the experiments and what the
Mm-hmm.
experiments found and how they were interpreted and whether that was a correct interpretation. It's an extraordinarily difficult book to read, and I hazard to guess that it would never get published today, because the publishers would say, who's going to get through this? But that's what you need to do to understand the nature of a science. You have to understand not just what you're being told is true, but the evidence for why you are being told it's true, so you can judge whether that evidence is valid or not. And so again, in physics, you'll start with Newton's laws, because you didn't need the Newton managed to work those out without a lot of technology, and then you move through things like Maxwell's equations, and when you get
Mm-hmm.
up the Michelson-Morley experiment, you learn not just
Yeah. So
who
so
discovered it, but based on what evidence.
and so what
And
are the
this doesn't
origins?
exist.
Do you do
Okay,
you
so obesity research, um, In the 19th century, actually, it's interesting because I'm going to write yet one more book on this history. There was some fascinating work being done. Once you had microscopy and then different methods of staining tissues, microscopists, of which some physicians specialized in this, were able to begin to study fat cells and fat tissue and the origin of fat cells and fat tissues. And they would study it in fetuses, they would study it in frogs and tadpoles, and whether or not is this a separate tissue or adipocytes, just connective tissue that fill with fat, or are they separated? So that science starts to develop, but it's not seen as now. Obesity is not a major issue at the time. Some physicians are discussing it, but not researchers in any meaningful way. The second half of the 19th century, from the 1860s onward, is considered the beginning of the modern theory of nutrition, and it was based on the creation of a calorimeter by German scientists Voigt and Pettenkofer. Mm-hmm. The calorimeter allowed you had always been able to measure the energy in foods by burning them in a calorimeter, but now Voigt and Pettenkofer created a calorimeter that you could put an animal or a human in and measure the energy expended. And virtually from 1869 or so through 1920, all of nutrition science was studying protein metabolism, because you could measure the protein nitrogen in the urine. It depended on what you could measure. All science always depends on what you could measure. And the beginnings of some work on vitamins and energy expenditure, calorimetry. So calorimetry dominated the science of nutrition. If you read nutrition history books written in the 1930s, virtually every chapter is on calorimetry or protein metabolism. And so by the late 1890s, the only science, in effect, the only technology that the physicians had to make sense of obesity was these measurements of energy intake and energy expenditure.
Mm-hmm. And so
meanwhile,
the use of a calorimeter like this, the invention of that device, the types of people thinking about that, a lot of people with a physics or engineering mindset, this is related to the origins of just thinking about obesity as a matter of being fundamentally energy in and energy out.
And because that's what they can measure. Mm-hmm. And meanwhile, energy metabolism, energy, the laws of thermodynamics had emerged. Physicists were talking about energy. Energy was basically the currency by which you understood life. The difference between animate and inanimate objects was one had energy, the other did not. So by the early 1900s, it actually first a Frenchman named Bouchard and then a German named von Noorden basically hypothesized that there's two types of obesity. This was always a general assumption. So there's obesity that could be explained by eating too much. Think Falstaff in Shakespeare. You had somebody who was overweight and they ate a lot. Therefore, you could explain that obesity as exogenous, caused by external factors, and the external factors were the amount of food they ate. But you always had people who suffered from obesity and did not seem to eat a lot. Mm-hmm. And these weren't the people that they came to talk about who might be lying about it. These were patients who came into these clinics and might stay for 6 months on a restricted diet and not lose weight. Mm-hmm. Or they might be kids whose parents checked them in because they had obesity and specific types of obesity, who the parents knew the kid wasn't eating a lot. They didn't have Snickers. Well, actually, in the US, they were just beginning to have Snickers bars, but they weren't kids who were hiding their candy wrappers under the bed that, we all thought about regarding the kids we knew who might suffer from obesity in college. Mm-hmm. So they knew that these people had very limited appetites. They knew that their obesity was resistant to caloric restriction for the most part. I mean, if you starve them, they would lose weight. But if you starve anyone, they'll lose weight, mm-hmm. lean or obese. So they had to explain them. And the theory was they called it endogenous obesity. And the assumption pushed by this fellow von Noorden was that endogenous obesity was caused by a sort of metabolic defect that produced a relatively low metabolic rate. So eating was normal. Energy expenditure was abnormally low. That was a constitutional problem. And then this exogenous, endogenous theory ended up taking over the world. Ultimately, though, it was always blaming obesity either on too much intake or too little expenditure. Mm-hmm. And so on one level, von Noorden is the Newton or the Einstein of obesity research, except that he was wrong. And he was thinking only in terms of the technologies, what could be measured at the time. Meanwhile, the science of endocrinology gets launched more or less also in 1869, but is this very
tenuous. It takes a very different track. There's a very different history and path there.
It takes till the 1920s before it really begins to blossom. And at this point already, that's when insulin is discovered and growth hormone is discovered and glucagon is discovered. There are very, very bright physicians thinking about endocrinology, but it's not metabolism and it's not nutrition. It's an entirely different field of research. And by the time physicians start evoking endocrinological explanations for obesity, they still think they're only evoking it first for this small proportion of cases that are endogenous, that can't be explained by how much the people eat. And then by the 1930s, they accept that actually the same hypothesis might hold for everybody, regardless of how much they eat. They need this constitutional predisposition to fatten easily. And that's an endocrine or neuroendocrine problem. And then World War II comes along and the whole theory vanishes. Like poof, the lingua franca. So the best medical science in the world, biomedicine, best science in the world is being done in Germany and Austria pre-World War II. But it's all the great physicists of that generation. Almost all of them were Europeans and German and Austrians specifically. And the Nazis party comes into power in 1933. Many of these were Jews. And by World War II, the medical community in Germany and Austria basically evaporates with the war. They have other things to worry about. And post-war, the lingua franca of medicine shifts from German to English. You no longer have to read the German journals.
So people literally they stopped working because they had to deal with the war. And then subsequent to the war, people just didn't know that history because they couldn't read it.
Yeah, I would argue it's undeniable. I would love to get the historian to care enough to try and prove to me that I'm wrong. I mean, it's blindingly clear in the research. And then you also get this other phenomenon post-World War II. So the gravitational center of biomedical science moves from Germany and Austria, from Berlin and Leipzig and Vienna to the US, because the US has not been demolished by the war. And you get this whole field of young physicians and medical researchers who come out of the war. And then in the post-war, launch into research projects that the National Institutes of Health is now funding. And they read the American literature. They have zero desire, and for good reason, to not read the German literature. So if you imagine a whole world of physicists, in physics, we didn't have this problem because all these European physicists were embraced by the US and England and the Allies, because we had nuclear bombs to build and we were afraid the Germans would beat us to them. So the Manhattan Project, for instance, is full of German and Austrian Jews who are fighting the Nazis by building a nuclear bomb. So all this science and physics moves west with the war. But in medicine, public health, we wanted nothing to do with these people. And so, they flooded into the US. They weren't hired. Arguably the most thoughtful researcher in endocrinology and genetics ends up working at the Hospital of Medical Evangelists in Los Angeles, a Jew named Julius Bauer, who fled Austrian 38. The Ivy League institutions, which are dominating this research, want nothing to do with these people. And this theory evaporates. And meanwhile, these young doctors who flooded into the field just assume the obvious, which is that people get fat because they eat too much. And it seems so obvious that they never question it.
Mm-hmm, mm-hmm. And
And they have no.
yeah. And so the energy balance model is basically saying obesity, leanness, how much weight you put on, it's all about calories in versus calories out. If you're in positive energy balance, you're consuming more than you're burning, and therefore you will gain weight. And that the obesity epidemic and the patterns of obesity we've seen in the past decades, they are due to some combination of people eating more and more highly palatable, readily available food, and together with that, perhaps being more sedentary, moving around less. When we actually measure those things, when we actually measure things like active energy expenditure, basal metabolic rate, caloric intake, is that what's actually happening?
Well, you can, well, so the positive energy balance. So the idea is, the law of thermodynamics. So delta E, the change in energy in a closed system, we won't get into the fact that humans aren't closed systems, but is equal to the energy in minus the energy out. Basically, what it's saying is energy is conserved. It's never created from nothing. So therefore, if the energy in a system increases, more energy has to enter than leave. And if the energy decreases, more energy has to have left than entered. There's an equal sign there. So it says delta E, the change in energy, is equal to intake minus expenditure. Mm-hmm. And that just says that the two sides of the equation are equivalent. So if you get fatter, you've taken in more energy. If you've gotten heavier, if your body mass has increased, and there are ways to get around this that probably have no physiological evidence, but for the most part, if your body mass increases, you will have taken in more energy than you expended. And then the energy balance model assumes causality there. There have been papers written in the past few years saying we don't do that. And we acknowledge that there is no causality, that this change in this equation is just telling you that the two sides of the equation are equivalent, not that one causes the other. But anytime you have someone believing that obesity, that the driver of obesity is increased food intake. So for instance, the theory with ultra-processed foods is that they are so, you use the phrase highly palatable. They taste so damn good. They're addictive. We just can't say no to them. So we overeat. And as soon as you use a word like overeat, you are assuming that that's the cause of obesity. And this is now an energy balance model. It's wrong on this fundamental level, which is that the world is full of lean people who eat excessively. Mm-hmm. And don't get fat. I mean, mm-hmm. excessively. They eat enormous amounts of food, mm-hmm. And don't get fat.
Mm-hmm. There's a lot of people for which they're eating the same amount of calories, they're eating a similar diet, but one of them is packing on weight and one of them is not.
Yeah, and I mean, people always knew this. Again, one of the fascinating aspects of the research community, the research literature, like when you read the German literature, which you can now obtain and translate thanks to ChatGPT and other AI programs will do a remarkable job translating these. The researchers at the time, they knew this theory had problems. And in fact, they spent decades trying to demonstrate that that people with obesity who didn't eat a lot expended less energy than lean people. And they couldn't do it because people with obesity tend to depend. I mean, it's difficult. Who do you choose as your comparison? But people with obesity weigh more than lean people, so they tend to expend more because their bodies require more energy to fuel. So there were 20 years of research literature that basically said this whole idea of reduced energy expenditure is crazy because there's no way to measure it that it's meaningful. And you could always find two people of roughly the same size who have huge differences in energy expenditure. So what does the energy expenditure tell you about their obesity? And we have to find a different way to do it. And that's when a different theory was proposed, which is that fat tissue in some people was predisposed to get fat. They didn't know what was regulating this when it was first proposed in 1910, but all that was then worked out over the next 50 years. And that's when we get into the competing model. But this energy expenditure, I often want to ask people who believe in this idea that it's all about overeating. And again, in the energy balance models, they will say that explicitly. And by they, that's the proponents of these models, which are led by Kevin Hall of NIH and John Speakman, a very influential obesity researcher who has joint appointments in Aberdeen, Scotland, and in China. And so the explanation now is it's a sort of, it affects energy intake, ultra processed foods and hyper palatable foods affect energy intake on a subconscious or unconscious level. So you can't accuse people of eating too much, of having inadequate willpower, because all this is happening at a level beneath which willpower, but they're still eating too much. And the reason they're eating too much is because the foods available make it too difficult not to. But then you're left with the question, what's the difference between a lean person, invariably the people promoting these theories, and a person struggling with obesity? And the only answer I could find is that the lean person can resist overeating in this ultra processed food environment, and the obese person cannot. And now a theory that has been carefully phrased to avoid the implications of willpower starts to look a lot like a theory that's blaming willpower as the problem. It's a question I always want to ask these people is, I wanted to sit in a public square with some of these obesity researchers, and it gets very uncomfortable. But as somebody, with extreme obesity walks by, say to them, do you really think the problem with that person is in their brain and their inability to control their food intake or to eat in proper moderation? And this could be a 50-year-old woman, a 30-year-old man, a 12-year-old child, or is it simply possible that the problem is in their body? Their bodies are accumulating massive amounts of fat. And if they eat more than you and I do, and we don't know if they do or not, maybe that's because their bodies are trying so hard to store fat. Just like,
well, I think another key observation here that aligns with what you're saying is if you just look at childhood obesity, children, practically by definition, right, their brains haven't developed yet, so they haven't developed as much willpower as they will as adults. But we see skyrocketing rates of childhood obesity, and the children never used to. It's not like the children used to have more willpower. They've always been little kids that are running around like little kids.
But the problem with when you have an incorrect paradigm, you'll have an explanation. Well, any paradigm in theory gives you an explanation for all the major observations. For instance, one epidemiological association, right, is that bottle feeding, breastfeeding is associated with lower weights and better metabolic health in children, and bottle feeding is associated with higher weights and worsened metabolic health. So how do you explain that? Well, maybe the kids who bottle feed consume too much of the formula because the parents, and I mean, there are papers out there saying that, look, the parents don't know when to stop. So they want the kid to finish the bottle, whether the kid's hungry or not. So they keep foisting the bottle on them, or with the breast, they can't tell if the breast is full or not. So they let the kid choose when to stop. So instead of suggesting the alternative hypothesis, well, people who bottle feed and people who breastfeed are different types of people. That's one possibility. If it's causal, maybe it's the macronutrient content of the breast milk versus the bottle milk. But now you need a theory other than calories to explain it. But if you believe that it's all about how much the kid eats, you can create an observation where, hey, these mothers just won't stop feeding the kids because they want the kid to finish the bottle on schedule, whether it's hungry or not. And then you train it to overeat. And now we have a child who has been trained from birth, in effect, to overconsume calories. It's
So
crazy.
one of the major models that is a competitor, a different model from the energy balance model, is what's often called the carbohydrate-insulin model. And can you tell us a little bit about what that is and how it developed and when it developed?
Yeah, but can I ask if we can hold on for 1 second while I replug in my fan and my light? I
Oh,
unplugged
yeah,
the
yeah.
fan.
Yeah,
It's
go for it.
like 80 degrees here in Berkeley. My office is at the top of the house, and we don't own
Yeah.
air conditioning because we never needed it.
Ooh, yeah. No, I'm in Seattle. Today's a pretty hot day in Seattle as well, but the
Yeah.
AC is on
Okay,
here.
hold on 1 sec.
All right, we're just taking a short break here while Gary tends to his setup. But obviously, Gary is a wealth of knowledge when it comes to not just the ongoing research world as it relates to obesity and diabetes, but the history of science here. And I definitely am a firm believer that understanding the history of ideas and the history of fields is very, very critical if you actually want to understand what we know, what we don't know, why certain ideas were developed, why certain models gain favor, sometimes despite the fact that they are lacking in key ways. And so, I'm sort of a history of science nerd and have a lot of appreciation for people who really understand what the ideas are and where they came from and how they developed.
Yeah. How's that?
Okay. Yeah. Good to go. Yeah. So
Fan isn't an issue. Okay.
the carb insulin model. What is that, and how did it come onto the scene?
Uh, okay, so the carbohydrate insulin, sort of the dietary implications, or the dietary implications of the bigger theory, which is that obesity isn't an energy balance disorder; it's a fuel partitioning disorder. It's not about how much you eat; it's about what your body does with what it eats. This was the competing hypothesis in Germany and Austria. It was first suggested in 1910, basically that some people are predisposed to store calories as fat. Their body preferentially stores calories as fat, and it doesn't have to store a lot. So if you store, let's say you eat 2,500 calories a day, which wouldn't be unusual for somebody my size at least, and your body stores 0.1% of that to excess every day. So 25 extra calories go into your fat tissue every day that don't come out. Is that right? Is that 0.1% or 1%? 5 is
Yeah,
1% of,
25 would
yeah,
be
that's right,
yeah.
1%. Anyway, it's just that much, those 25 calories a day stored as fat, as excess fat, will accumulate to 2.5 pounds of fat a year or 25
Hmm.
pounds of excess fat a decade.
Hmm.
So a tiny amount of excess fat storage could explain even massive obesity. Is not that
Yeah.
if somebody gains
Yeah.
100 excess pounds in 20 years, so they weigh 300 pounds when they should weigh 200 pounds, that 100 excess pounds is basically 100 calories per day that their fat cells stored that the lean version of them would not have stored. And that could easily be a neuroendocrine. So the nervous system regulates fat storage, and hormones regulate fat storage, and there's a balance between them. Nerves stimulate what's called lipolysis, which is a mobilization of fat from fat cells, and the hormone insulin primarily inhibits lipolysis. So higher your insulin levels, the more fat you store. Again, this hypothesis was first suggested in 1910 in Germany by a fellow named von Bergmann, famous physician. And then the war hit, World War I hit, obesity research pretty much shut down. And beginning around 1920, it kicks up again. They start discussing all the failures with these energy expenditure experiments. And von Bergmann's idea gets more and more credibility. And then this Austrian endocrinologist named Julius Bauer takes it up and runs with it. And by the 1930s, it's pretty much accepted in Germany and Austria as the viable hypothesis, which is that obesity is basically caused by this preferential storage of calories into fat, phenomena that's regulated by the endocrine system, hormones, and the nervous system. And people get fat because there's an imbalance in these systems, and you end up, in effect, post World War II with people who are still studying fat metabolism, linking all this to insulin as the dominant hormone. And insulin is a hormone that dominates fat storage. So we secrete insulin primarily in response to the carbohydrate content of our diet. There are other fields of science that are implicating sugar and other fields of medicine implicating sugar and refined carbs and obesity and diabetes and heart disease epidemics in countries undergoing nutrition transitions. And by the 1960s, you have the low carb or ketogenic diet induces weight loss without ever telling people they have to eat less. Whether they do or not is a separate issue, separate but related. So the carbohydrate-insulin model basically says that insulin dominates fat storage, insulin secreted in response to carbohydrates. The more carbohydrates you consume, and specifically refined processed grains and sugars, the higher your insulin levels, the more likely you're insulin resistant, the more likely you're storing calories as fat. And among the evidence, you can do clinical trials, which have been done, where you tell people, in effect, to eat what was called Atkins when I was growing up, and in the past 15 years is known as keto. So you say, look, don't eat carbohydrates, eat as much as you want, cut out the carbs, eat the protein and fat.
Yeah. And so the idea here, the idea here is if
significant amounts of weight.
Yeah. So the idea is you can cut out the carbs without having to worry about cutting total calories. And this, in theory, will keep your insulin lower, and so will not favor fat storage as much.
Yeah. In fact, if you cut out the carbs, you'll pretty much minimize insulin. I mean, you could get it lower through various other, you could lower protein consumption also, you can fast, but that's as good a way as any to minimize insulin secretion. And when you minimize insulin secretion, you minimize the effect of insulin on the fat cells. It's upregulation of fat storage, this enzyme called lipoprotein lipase, and probably more importantly, it's inhibition of lipolysis. So insulin can, even at tiny, tiny circulating levels, will shut down lipolysis and shut off the flow of fat, the mobilization of fat from a fat cell.
And so based on sort of the totality of your knowledge here, both of the ongoing science and the history, how effective is lowering insulin, whether it's through carb restriction or by other means, how effective is lowering insulin at helping people burn off fat? And how does that influence how we should, favor or disfavor one of these models over the other?
Well, classic evidence is type 1 diabetes. So in the type 1 diabetes, you're insulin deficient. Your pancreas can't secrete enough insulin, and these people prior to insulin therapy became emaciated. They could not store calories as fat, even when what is technically called hyperphagic. So because they also couldn't really efficiently use the glucose in their bloodstream, they were hungry all the time and died emaciated. And this actually led to this theory in the 1920s, pushed by one of the pioneers of the science of endocrinology named Falta, which is that a functional pancreas is necessary for fattening. Without insulin, you cannot make anyone, animal or humans store significant calories as fat unless you give them insulin therapy. The flip side is type 2 diabetes, where these individuals are insulin resistant. They have both high blood sugar and elevated levels of insulin, and type 2 diabetes associates so closely with obesity that most physicians and most diabetologists have always thought that it's the obesity that causes the insulin resistance and the type 2 diabetes. 1964, 65, Rosalind Yalow and Solomon Bersin, who won the Nobel Prize. Yalow won the Nobel Prize for discovering the radioimmunoassay that allowed insulin levels and other hormones to be measured in the bloodstream accurately. They proposed that since insulin was the most, as they put it, the most lipogenic hormone, it's quite likely that the insulin resistance causes the obesity, not the other way around. But by that time, there was this central dogma.
Yeah. So if fat storage and obesity are largely about insulin, and insulin is driven largely by carbohydrate intake, everything that you just said makes sense. One of the arguments I sometimes hear people make is, okay, well, if the carb insulin model is correct, or at least more correct than the energy balance model, why is it that we can find historical examples of peoples that have high rates of carb consumption but low rates of obesity and diabetes? So, for example, in Southeast Asia, they've historically eaten lots of rice. In Papua New Guinea, they eat nothing but like sweet potatoes. And historically, until very recently at least, those populations weren't suffering from the metabolic ailments that are so widespread today. So, how does that square?
Well, and that was always the obvious. I mean, that is the obvious counter example. Like Southeast Asia, 2 billion people or however many today, spending their entire lives eating carbohydrate-rich diets, and they are very historically, traditionally, very far from obese. The argument is that, and this, one of the frustrating aspects of my life. So I write books, right? I have now co-authored maybe half a dozen academic research articles, but my profession is to write books. I'm a journalist. So, and the people who criticize the science that comes out of my book are invariably the people who know that I'm wrong and so don't have to bother reading my books. And so the Southeast Asia thing is like, well, you spent 5 years researching the obesity science. Did you not notice that there are 2 billion people in Asia eating carb-rich diets? And I mean, it's the first question you should always ask. And the answer is the hypothesis isn't that carbohydrates cause obesity. The hypothesis is that the addition of refined carbohydrates and sugars, fructose-containing carbs, when added to a population's diet, will cause that population to experience an obesity epidemic. It'll basically predispose the individuals in it to then being susceptible to this carbohydrate insulin model. This is not spelled out in our papers, and it should be. And I often argue with my co-authors that we have to be more specific here. So the idea is you add refined carbs and sugars, and I actually think the sugars are probably the critical element. Again, if you believe in the seed oil hypothesis, you might argue that seed oils are the critical element. But you produce a human who tends towards insulin resistance, elevated insulin levels, and then all carbohydrates become problematic.
Yeah. Well, one of the someone I've had on the podcast before, who I really respect as a rigorous thinker, is Dr. Oren Davinsky. And he wrote a nice little commentary on a paper to do with the carb insulin model. And the gist of it, at least part of it, is that it should really be called the refined carbohydrate insulin model, because certain refined carbohydrates are much more potent at driving insulin than other types of carbohydrates. And, one of the things that he pointed out that I thought was interesting is, he says, quote, it is rare for individuals or populations to develop obesity without chronic consumption of abundant, greater than 20% of calories from refined carbohydrates. And apparently there's basically no population that's ever been observed where obesity rates are greater than 1%, where they're eating largely unrefined or minimally processed carbohydrates. Right. And so that seems to be a key distinction, refined versus unrefined.
Okay, and I've known Orrin for a decade, and we discussed this letter when he wrote it. And my counter argument that, well, first of all, historically, it originally was a refined carb hypothesis. So this
Mm.
British naval researcher, Peter Cleve, who was one of the founders of this theory, one of the initial proponents, wrote a book called it was Saccharin. How did he phrase it? Well, he called it the saccharine disease because he didn't want to call it the refined carbohydrate disease. He said if he called it the refined carbohydrate disease, it would become one of these acronyms, and Cleve couldn't stand acronyms. So instead, he called it saccharine to rhyme with wine, so as to be differentiated from the artificial sweetener. But the theory was refined carbohydrates. A lot of Cleve's perspective mechanisms were, I would say, wrong. I certainly disagree with him when, they were simplistic, but his observation was basically the same observation that Orrin is making, and Orrin read Cleve just like I did. The counter argument that I said to Orrin is that once you've been living or you're born into a population that eats a high percentage of calories from refined grains and sugars, and again, I suspect the sugars are critical, then you're born predisposed to getting fat in a carbohydrate rich diet. And if you remove the sugars and refined grains, we might not make a significant difference. This is the kind of answer that a clinical trial would determine. And I think the anecdotal and clinical trial experience with Atkins and keto is that many of us, if we want to lose weight, have to restrict all carbs. It's insufficient once you're on this spectrum towards obesity, overweight, diabetes, pre-diabetes, to think that you can put it into remission or reverse it by merely improving the quality of carbs. Possible,
Mm-hmm.
but I don't see significant evidence for that. So ultimately, depending on the individual, if you're talking about a member of a traditional culture in Africa or Southeast Asia that was born into a population eating a unrefined whole carb diet, we'll call it, then they're fine. They could eat all the carbs they want. The argument would be lean people can eat all the carbs they want. They've demonstrated that they can on some level, but the rest of us, it's insufficient that all the carbohydrates in the diet are causing problems because our metabolic health has already been disrupted by the sugar and
Mm-hmm.
refined
Mm-hmm.
grains. So um, it's just in my book, and I said this to Lauren, in my book, Good Calories, Bad Calories, would probably be 20 pages shorter if I just said carbohydrates every time I instead said refined carbohydrates and sugars.
Mm-hmm.
But it's kind of author's choice which one they want to use the
Yeah. Yeah.
title.
Yeah. But I think, one of the points here is that, what you need to do to achieve a certain goal is going to depend on the metabolic state you're in. So for example, someone who is diabetic and has been insulin resistant for years is probably going to respond to different combinations of carbohydrates and other macronutrients very differently than someone who is only, pre-diabetic versus someone who's lean and metabolically healthy.
Right. And it's interesting because much of the vitriolic pushback I've gotten over the years, I don't know if I still get it because I muted these people, but maybe they get bored with me, is this community of bodybuilders who require, eat significant carbohydrates, and it helps them with their bodybuilding. They're still lean, they can be cut, it's not an issue. So for them, if it's not an issue for them, it's not an issue for anyone. And I would argue, just as we could acknowledge that the macronutrient composition of the diet makes a huge difference if you have diabetes. And type 2 diabetes and obesity, as we said, are so closely associated that there's a trend to refer to them as diabesity. So why is it out of the question that people with obesity are particularly intolerant to these carbohydrates
Mm-hmm.
too? But rather than manifest it immediately as high blood sugar, they manifest it as excess fat.
Yeah.
storage.
Well, I mean, not only are there differences between people in terms of their lifestyle, so obviously, bodybuilders versus sedentary people, even if you match them in other ways, right, their lifestyle is going to have a big impact on how their body's processing calories. Another thing that I like to point out that, I learned recently to people is there are very big genetic differences that have to do with metabolism that dictate how our bodies process different calories. So even just among, I had a population geneticist on a few months ago, and one of the things they've uncovered there is one of the major locuses of genetic diversity for humans, just among white Europeans even, is the fatty acid desaturase enzymes. So people can vary dramatically in the enzymatic capacity they have to deal with different types of fatty acids. And so, people are going to differ in terms of the way their diet manifests in their physical body, even if they're matched for other lifestyle factors, because there are, at the end of the day, intrinsic differences in us that have to do with genetics.
And there's sort of two fundamental observations that I think are important here. One is the point Oren made about the percentage of refined carbs in the diet, but this idea of a nutrition transition. So every population anywhere in the world that goes through a nutrition transition from whatever their traditional diet is. So it doesn't matter if it was Southeast Asians living on rice and wheat, or Maasai living on the blood and milk of the cattle that they're herding, or Siberian reindeer herders, or the Irish potato farmers,
high
or
carb diets, high fat diets, low protein, high protein.
It doesn't matter. You start eating a Western diet, trading with the West, you eventually manifest the epidemics of obesity, diabetes, and all these chronic diseases. This observation gets tricky, right? Because when you start trading with the West, you also start having interactions with Western doctors who might be more likely to notice the symptoms of these diseases and diagnose them. But for the most part, it was such a consistent observation that we'll assume it's true. So that tells you right there that the trigger of obesity and diabetes epidemics in populations is likely to be unrelated to genetics, because it happens in all these populations regardless of their genetic racial background. Pretty much in the same patterns as well. But in those populations, you get huge variations depending on what you eat. And you could see that, just look around America. We all, for the most part, ate pretty much the same thing. And some of us stayed lean, and some of us became obese, and some of us became diabetic. Then that's when you need very careful science, once you're looking in a population, to establish what factors might be driving this. A metaphor that was used 50 years ago by this guy, Dennis Berkey. Imagine a population where everybody smokes a pack of cigarettes a day. How do you determine the driver of lung cancer? Because you experience a lung cancer epidemic, but everybody smokes the same amount of. So you've got to, we could do it because there were smokers and non-smokers we could compare.
Yeah,
and
it's more difficult with diet, since a very, very, very high proportion of people are eating the so-called Western diet.
Pretty much the same thing. So then you end up, it's sure genes play a role in how we metabolize, how we, our bodies react to the foods we're eating. But the job is to establish which foods are triggering obesity and diabetes, which we know is relatively simple from the first observation. It's got to be something that moves with Western diets from population to population. And the part of the basis of the carb-insulin model was the people observing these nutrition transitions before they got complicated in modern times were people who were saying that sugar and white flour are necessary and sufficient to create an epidemic of obesity and diabetes. One of my arguments against the seed oil hypothesis is they didn't mention seed oils. Did they not notice them, which is possible? Or was it that sugar and white flour were necessary and sufficient, seed oils were not, which is also, to me, more likely. But
We don't know for certain.
We don't know. Clinical
Um,
trials are necessary.
one of the things I want to ask you about, so there's a two-pronged thing I want to talk about here. So I want to talk about, on the one hand, the relationship between carbs and fats. In other words, the ratio of carbs to fats and how meaningful that is as it relates to the development of obesity. And I also want to talk about one of my big pet peeves in the scientific study of feeding and obesity, and which is there's widespread use in the literature, especially the animal literature, of so-called high-fat diets. And researchers often, I've literally asked them, and I also used to be one and work with them, so I know this is a widespread phenomenon. The so-called high-fat diet we often give to rodents and other experimental animals, oftentimes the researchers don't even know what the actual macronutrient composition was, except that it's quote unquote high fat. But one of the things you pointed out in one of the papers that you are an author on, you shared with me, is that these high fat diets that are used experimentally, high fat in scare quotes, often contain 20 to 50% by weight of refined carbohydrates, including things like starch and sucrose and so forth. And so I'm wondering if you can comment on that. What do you know about the relevance of the fat to carb ratio in terms of driving fat deposition and how important that might be?
And the answer is I don't know. Again, because you can have two people eat the identical diet, the identical fat carb ratio, one becomes obese, one becomes lean. Is there a ratio at which, other than the very low ratios characteristic of ketogenic diets, where one would not have become fatter than the other? And the answer is I don't know. That requires clinical trials to tell us. This issue of being what the ketogenic diet does, or carnivore, is, like I said, it minimizes insulin. So it takes the whole ratio thing out of the question. It just says get rid of the carbohydrates. Like, carbohydrates are fattening, don't eat them. And when you don't eat them, you tend to return to a healthy weight. That's kind of the simplest way to describe this hypothesis. But whether there's a proportion of carbs to fat that makes a difference, and what proportion of those carbohydrates have to be refined, and what proportion of those carbohydrates have to be fructose, and what proportion of the fructose containing carbohydrates have to be in beverages, all of this could matter. And it's all guesswork. When people who are lean and healthy ask me what they should do to remain lean and healthy, from my perspective, I say basically, stay away from sugar and white flour, and mostly sugar. It's just, and I'm basing it's based on my interpretation of the evidence, but there are no clinical trials to
and when you say sugar,
confirm that.
One thing I want to ask you about too is glucose versus fructose. So, my understanding, I've talked about this on the podcast before, is that they are probably both contributing to obesity and diabetes, albeit in different ways. So glucose obviously drives insulin. Glucose is going to be pretty much the best thing at driving insulin. Fructose, my understanding is it doesn't drive insulin so much, but it can drive insulin resistance through other means. And so can you unpack what the difference between glucose and fructose is with respect to insulin resistance, obesity, and diabetes?
Okay, and that's the general issue. So glucose stimulates insulin secretion. Your pancreas is responding to the blood sugar level, and the blood sugar level is glucose, 97% or some number like that. The fructose, the fructose that gets through the small intestine, which isn't a lot of it, ends up going through the portal vein to the liver, and then your liver cells primarily are this metabolize the fructose. Many of the cells in the body can't deal with the fructose. There's copious biochemistry from the 70s, 80s, and 90s. Many of it, much of it done in Israel, demonstrating that fructose, the liver has trouble metabolizing the fructose, converts it into triglycerides. The triglycerides associated with higher risk of heart disease. You also get this insulin resistance that starts in the liver and then becomes systemic. So the way I see it, and I have to say, I never took a biochemistry course in college, and if I had, I probably would have been a C student. The fructose is driving insulin resistance. The glucose is not. But and this is the key factor, we never consume fructose independently of consuming glucose. So a sugar molecule, sucrose, is a fructose molecule bonded to a glucose molecule.
Mm-hmm.
They have either split up by the time they make it to the GI tract or shortly thereafter, and they go their separate ways. But you always see the action of the fructose in the context of the insulin secretion in response to the glucose. And in fruits, where you'll get both sucrose and glucose and some unbonded fructose, you see that you never get the fructose without the glucose. Mm-hmm. And usually it's in something close to a 50-50 mix if it's something we consider sweet. So again, it's impossible to say that. You can argue that fructose is a problem because without it, we would just be consuming glucose and we might not then be insulin resistant and we might all be fine and metabolically healthy, but you never see that. You can feed fructose, and there are animal models where they feed them fructose alone, but now you're doing something that's the animal never evolved to do.
Yeah.
And so you can't trust, which by the way, brings me back to the animal models and the high fat diets. Yes, it's true. They always almost invariably they contain significant sugar content. The animals often don't want to eat it without the sugar. The issue is more profound than that. So one of my favorite learning experiences from living with physicists in the 80s was that they considered the term model dependent. So if they got a new paper and they saw that the theory in the paper, the interpretation was model dependent, the model dependent was a synonym for I don't have to read this because life is short and I never know what assumptions go into the model. Mm-hmm. A lot of the research on animals tell us, like using a high-fat diet for mice, tell you what makes mice fat. But mice evolved, we've been separated from mice evolutionarily for millions or tens of millions of years, and that's a lot of time for us to evolve different responses to the macronutrient content of the diet. So you can often ask yourself, oh, and I've given a lecture to this effect, and I was thinking about writing it on my Substack, writing it up, but you have to assume that what makes the mouse fat is what makes the human fat. But if you did the experiment on pigs, you'd have to assume that it makes the pigs fat. And they used to use dogs primarily for medical research. You'd have to assume the same experiment makes dogs fat and mm-hmm. cats, although cats are obligate carnivores. I mean, it's all it tells you is that this diet makes a rat fat. And the high-fat diets are often 60% fat. Rats in the wild and the rat chow is like 6 to 10% fat diets that they consume. So they're eating 6 to 10x their normal fat content. Humans typically eat in traditional populations 30 to 40% fat content. So you can't even multiply that by 6x because you get more than 100%. Mm-hmm. So you assume that it's this package of one assumption after another. Yeah. So that if the researcher wants to blame the fat content of the diet on obesity because they've read that high-fat diets cause human obesity, even though a high-fat diet like a ketogenic diet in a clinical trial can be demonstrated to reverse human obesity, you just basically believe what you want to. A good scientist knows that an animal model tells you what's happening in the animal. If it's a biological mechanism, you could assume it may have been genetically conserved through evolution, but if it's environmental input to that mechanism, you can't.
So when we think about people who are obese today, right now, who want to lose that weight and become lean or at least less obese, if they are committed to making dietary changes and they want to try that and really try it, do you think there is a clear answer there in terms of a dietary strategy that's relatively likely to work for a high proportion of people? Is the answer to this potentially to focus on getting your insulin down through carb restriction, or would you have another answer, or does it really just depend on the individual?
I mean, there's always going to be individual variation. And people are going to change with time too. So even I'm 68 years old, if I eat what I ate 20 years ago, I will be fatter now than I would have been than I was 20 years ago because my body has changed its response to it. I do not know why. I don't even know how to establish why. The carbohydrate insulin model says, in effect, that if you want to achieve and maintain a healthy, be as light as people prefer, but if you're overweight or obese and you want to maintain and achieve a healthy weight, you have to minimize your insulin levels. That of a successful diet is a diet that minimizes your insulin levels, and that will allow you to lose weight without being constantly hungry, to lose fat, and to sustain it. Is that true? You know, clinical trials suggest it could be. Anecdotal observations suggest it is for at least the diet is for some of us. What proportion of people would succeed on this diet can't be said because the clinical trials have never been done in a way to actually establish that. I know physicians who will say that the people who adhere to abstaining from who successfully abstain from carbohydrates inevitably see significant weight loss and the remission of diabetes, improvement of heart disease risk factors, but the physicians could be fooling themselves. There are clinical trials you could do to establish, and I've argued this. My latest book was called Rethinking Diabetes, and one of the opening epigraphs was from Elliot Jocelyn, who was a leading diabetes clinician of the first half of the 20th century. And Jocelyn said the measure of a diet is determined by the people who adhere to it, not by the people who don't. So what you want to do in a clinical trial is say, take the 100 people and randomize, or 200 participants, randomize them to two different dietary approaches, an intervention and a control. And the intervention is a carbohydrate restricted diet, and then give them the food and keep them on the diet for a year and make sure that they eat only the food they're given and all of the food they're given and no other food. And then see what happens at the end of the year. And that might tell you what proportion of the people for whom this diet works. But absent that kind of study, we don't know. I would think it works most of the time, but I don't know what
we've talked a lot about these competing models of obesity, where they came from, some of the history. We also talked a little bit about how sensitive people get when it comes to the issue of invoking, willpower or human agency as a component of the explanation for why people put on weight. With that in mind, we've got these new GLP-1 drugs that you mentioned a little bit before. A lot of people are taking them. They're getting a lot of attention. New versions are being worked on and so forth. What is your basic take on these new GLP-1 drugs in terms of how well they work, whether or not they're likely to have side effects that people maybe aren't paying attention to yet or haven't seen yet, and how the use of those drugs to lose weight might compare to lifestyle changes to lose weight? I think you're muted.
Excuse me. I muted to clear my throat, and then I forgot to unmute, and then cleared my throat once I did. The GLP-1 drugs are interesting. A clinical trial I would like to see is to compare the use of these drugs for a year with ketogenic diet for a year. Again, you would have to set up the trial in such a way that the participants adhere to the diet, but it would be interesting to see whether you got more or less weight loss with the diet. The mechanism is interesting. I mean, on one level, the drugs are no longer, these are drugs that have been designed to have very little in common with the physiological molecules themselves. So whatever GLP-1, glucagon-like peptides are doing when they're secreted from the gut in response to food consumption is very different now with these drugs. They survive in the bloodstream much longer. They get into the brain at much higher doses. The assumption, again, you have this observation that people who go on the drugs lose weight and their appetite is inhibited. So the assumption is based on, in effect, energy balance thinking and some experimental observations that they lose weight because their appetite is inhibited. So they eat less, and that's why they lose weight, and the drugs help them eat less. And I've seen in the literature people referring to these drugs as appetite inhibition drugs because that's one of the effects they have. It's conceivable that they fundamentally affect the way the body. I mean, they do have other effects. They slow gastric emptying, so they will lower the glycemic index of foods that are eaten, which will lower the insulin response to those foods. They stimulate glucagon secretion. They reduce insulin resistance, even though endogenously they stimulate insulin secretion in the short term, they also induce insulin sensitivity in the long term, so you get less insulin under the curve. The question I would want to know is, do they fundamentally change the partitioning of fuel in the body from storage to oxidation? In which case the increased oxidation of fatty acids, this is this fuel partitioning model I was discussing in more detail. If you mobilize fat from the fat cells and signal the lean tissues and particularly liver cells to oxidize that fat, according to this fuel partitioning theory and the theory of hunger that developed in the physiological psychology world that you may or may not have been taught when you were studying neuroscience and appetite at Harvard, that increased fatty acid oxidation would inhibit intake. So it's conceivable that these drugs change fuel partitioning. They would work on some level like ketogenic diets do, and the reduction in appetite is a response to the mobilization of fat from fat tissue and the burning of that fat rather than the reduction in appetite causing the mobilization. You flip the causality. There are 2 or 3 experiments that suggest that this might be the case in animals. I would love to see these experiments done in humans, and who knows, maybe we will at some point. They worry me. Any long-term drug therapy with a powerful drug worries me. And the example that I'll use, what got me worried was doing the research for my diabetes book, where among other things, I was studying the use of insulin therapy in the 1920s and 1930s. And when insulin therapy came in, it was a wonder drug. I mean, these kids with type 1 diabetes, mostly kids who were dying these agonizing, awful deaths, they were being starved at this point in the US anyway to try and prolong their lives. So they were hungry all the time. They were being starved on top of the hunger. They were emaciated and getting weaker and weaker and could be days or weeks from death. And insulin is discovered and they're given insulin therapy. And within hours, if they start to fill out and look healthy, and within days, they're almost back on their feet. And within weeks, it's like a miracle cure. And the physicians of the era used the term, spoke about this in sort of biblical terminology. These kids were resurrected, and the literature is full of these pictures of kids who look like, they had the Auschwitz victims, and then 2 weeks of insulin therapy, and they look like perfectly healthy, happy children. The issue is that so you save these kids' lives when they're young. They might be 8 or 10 or 12, and you've got a new drug, and it's a miracle drug, and then they're on this drug for the rest of their lives. And 10, 15 years later, they start manifesting the chronic complications of both the drug therapy and the diets that they were allowed to eat because of the drug therapy. And now they're still young. They're still in their mid 20s, early 30s, and now they start dying of all the complications that are familiar complications of insulin, both type 1, I mean, diabetes, both type 1 and type 2. So,
Hmm.
heart disease, kidney disease, neuropathies, limbs are being
Hmm.
amputated, they're
So,
going blind,
so
and it
they've
happens
traded
quickly.
yeah, they've traded one set of problems now for a different set of problems later.
Yeah, and if the diabetes specialists are they referring to the sort of epidemic of complications that washes over them, and they see it as the long-term complications of the disease, but it could be the long-term complications of the disease plus the insulin therapy because that's how they've kept these kids alive. And
Hmm.
then there's copious evidence afterwards that insulin therapy on its own creates some of these complications. So, and that it's a completely inappropriate therapy for people with type 2 diabetes, which is one of the messages of my book. But so anyway, that reading these case studies and Jocelyn's case studies from his clinic awesome and are available and you can read them and these kids are thriving and they're healthy and they're happy and for like the first time since their diagnosis and then over the course of 2 years their bodies just to use a non-technical term crap out and they go from the healthy happy and part of it I think is the insulin therapy and it just makes me worried about any long and there's copious stories like this in the mental health world with like benzodiazepines and other anxiety sleeping antidepressive drugs that long-term use gives the body time to compensate to the drug use and then you manifest consequences that you wouldn't see after only a year or two. So they're definitely, if it's not a wonder drug, nobody cares, right? Because then you don't stay on it for 20 or 30 years. They're definitely remarkable drugs. And for people struggling with obesity their whole life, it's like uh, terrific. But, and I mean, I would probably do it myself. And I've seen it help these drugs help people I know and love. But I worry about long-term use. And the younger you are when you start, the longer you're going to be on these drugs and the longer time you have to manifest unfortunate complications or consequences.
Gary, we've covered a lot already, and it's been fascinating. Is there anything you want to reiterate or final thoughts you want to leave people with around just the general topic of metabolic health or the causes of obesity and diabetes, things that people should keep in mind or think about?
Keep an open mind, basically. I mean, a lot of what the resistance, well, okay, two things. First of all, we have these obesity and diabetes epidemics. Obesity rates are the highest they've ever been. Diabetes diagnoses have increased 7 or 8 fold in the past 60 years. There's a very terrific journalist named Neil Barsky who has been writing about this for The Guardian recently. Um, Something is driving those increases. And it's not just that people are eating too much and physical inactivity, it's something about the Western diet. And it's a frightening. I mean, these drugs are driving the increases in healthcare prices. Again, $1 billion a day for diabetes. It's crazy. So, um, I want researchers to open their minds to the possibility that they've made pretty much some terrible errors in their underlying assumptions about the causes of these disorders. And that when confronted with out of control epidemics like this, that they're obligated to consider the possibility that the reason they failed to rein in these diseases is not because people won't take their advice and not because the food industry makes it too hard to do, but because their fundamental ideas are simply wrong. And I, spent 25 years of my life trying to get people to understand that possibility, and we're making progress, but not nearly enough. And that's, stay away from sugar because I think it's toxic.
Gary Taubes, thank you very much. Do you want to remind people where can they find your work? What's your latest book? What's coming up next? Things like that.
Yeah, okay. So I'm now writing a Substack with Nina Teicholz, although we may disengage a little bit by the time this comes out. It's called Unsettled Science, and I think people should read it and subscribe, because I think we're about the only two traditional journalists out there doing critical reporting and writing on these major topics of nutrition and chronic disease. Yeah, there are more now, but Nina and I are among the few. And my latest book is called Rethinking Diabetes. It's medical. It's a book about the history of medicine and as much about the philosophy of medicine as it is about diabetes itself. In many ways, I think it's the best book I've written. I think, again, physicians certainly should read it if they're treating diabetes, but it's a difficult read. It's not a how-to book. It's not a diet book. And I have a blog that I may shut down soon called at GaryTaubes.com. So.
All right, Gary Taubes, thank you for your time. Lots of interesting stuff to chew on from this. And for what it's worth, you look great for almost 70.
Good lighting. No, thank you, Nick. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form, and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure. And vitamin D is super important for the proper function of the immune system and for a variety of other things. So visit athleticgreens.com/mindandmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase.